All right, we still find ourselves working on normal distribution applications. This is the second problem. And this problem says Tom is trying to get into university. That university requires for entry that you score in the upper, above the 70th percentile. You need to get a score on their entrance exams, which is better than 70% of the people that take the exam. So in this particular case, this exam has a mean of 500. It has a standard deviation of 100. And Tom gets a score of 585. The question is, did he score high enough to be admitted? So let's just do a quick picture. Here's the distribution. That distribution has a mean of 500. It has a standard deviation, let's click it right there, of 100. And Tom scores 585. Let's just hold that in our brain for a second. What this is asking for is, where is the 70th percentile? Where is P70? P70 is that value along the x-axis such that 70% of the area under the curve lies to its left. That's what inverse norm is all about. So all we need to do is to calculate inverse norm of 70% for this distribution, the one with a mean of 500 and a standard deviation of 100. What inverse norm kicks out in this case is P70, all right? So I turn the calculator on, I hit second distribution, I look for inverse norm. It asks me what's the area. This area is 0.7. It asks me what's the mu. The mean is 500. And it asks me what the standard deviation is. It's 100. I paste, I hit it, it says 552. 552 is this answer. He scored 585. Tom's in. Okay, let's go do problem 3. All right, problem 3 has 3 parts. Frankly, if you can do problem 3 with great alacrity, then you're probably ready to move on. Problem 3 says there's a distribution. This distribution has to do with salaries. The salaries have a mean of 50, how can we do this? Let's go 50,000, a sigma of 20,000. And there are 3 questions. The first question, the first question involves what is the probability that a randomly chosen employee has a salary greater than 40? Let me get all the questions down here. The second is, what's the probability that a randomly chosen employee has a salary between 45 and 65? And thirdly, what's the probability that salary is greater than 70? Maybe I spoke too quickly, because in all cases we're going to make use of the normal CDF here, and you do have to be able to do problems in which you're looking for probabilities, normal CDF, as well as problems in which you are looking effectively for percentile points, inverse norm, all right? Well, let's go ahead and do these. Again, as I've done before, I'm going to draw, in each case, maybe we'll do all of these at once, okay? All of these at once means I'm going to need 3 distributions. These are the same distributions in all cases. The mean is 50, the standard deviation right there is 20, all right? First one says, what's the probability that X is I think I've got that wrong. I think the problem asks for X is less than 40. Okay? So, so this is 50. 40 is about right here. Let's go find this area. Okay, to do that, you go normal, CDF. Okay, what's the lower bound? Minus 999, 999. What's the upper bound? 40. What's the mean? 50. What's the standard deviation? 20. Okay, over to this problem. This is 50. We're looking for the percentage of employees, if you will, who have a salary between 45, this is 40, this is 45, and 65. Okay? How do we do that? Normal CDF. Normal CDF, lower bound is 45, upper bound is 65. Use 50, sigma is 20. And lastly, we're looking for employees who make greater than 70,000. That's this blank over here. Normal, this is the 70. This is normal CDF. 70 is the lower bound. Infinity, positive infinity, is the upper bound. 50 and 20. Okay? So, I'm going to pull out the calculator. Let's whip out all of these guys very quickly. Turn the calculator on, go to distribution, go down to normal CDF. I have minus 1E99 already in the calculator. I have the upper bound is 40, mu is 50, sigma is 20. All right? Paste that guy in, throw the calculation. It says quit, for crying out loud. Not sure why. So let's do this again. Normal CDF. Oops, starting to go crazy. Normal CDF. This one, upper 40, mu 50, sigma 20. That should work. And this time it works. Don't ask me why. And so this is, I'm going to call it, I'm going to call the probability that we're looking for as x less than 40 is equal to 0.3085. Okay? There's one answer. Let's do it again for the part B. I'm back down to normal CDF. This time I'm entering 45 as the lower bound, 65 as the upper bound, 50 and 20 as the mean and the standard deviation. In this case, P 45 less than X less than 65 is equal to 0.3721. Okay, final one. I'm effectively looking for P, what's the probability of being above 70. Note that 70 is 1 sigma away from 50. Yeah, so we probably remember that this area here between minus infinity and the mean is 50%. And the area between two single standard deviations about the mean is 68 by the empirical rule, which means this area is 0.34, means that this area is 0.84, which leaves this as 16%. Okay, so we better get 16% here. Back over to normal CDF. I'm going to hit 70, I'm going to hit 999, 999, 50, 20, paste, and the answer is 0.158656. There. there are the three answers. Here's problem three. Problem three, doing the three types of problems that you can do here, calculating a probability for values of x less than some value, between two values, or probabilities for values of x above some given value. All right, very good. Let's move on.